Hey guys, what's up? I hope you're doing great. Back with another video. Apologies for a long delay between this video and the previous video. I was unwell and wasn't able to speak much. But yeah, I'm back now. So we'll be studying Greedy 2 in this video. The video for Greedy 1 had already been uploaded before. If you haven't checked that out, please do so because that would build somewhat of a foundation. And in this video, we are going to discuss 3 problems. 2 are from Codeforces and then 1 problem from Leetcode itself. So let's get started. So the very first problem is rational Lee. The problem states that Lee has n integers a1, a2, so on to an in his backpack and has k friends. Lee would like to distribute all the integers in the backpack between his friends such that the ith friend gets exactly wi integers and each integer will be handed over to exactly one friend, and then they define something called as the happiness. And the happiness, what they're defining for a particular friend, would be the sum of the maximum and the minimum integer he'll get. So for example, any one of the friend gets 3 integers, maybe like 8, 6 and maybe 2. So now the maximum integer here being 8 and the minimum being 2. So the happiness of that particular friend would be 10. And in this way we'll try to maximize the sum of the happiness of all the friends. And we only need to print the answer. The way they have given the input is they have given us 2 integers n and k, that is the number of integers and the number of friends he is having, and then they have given us the n integers, and thereafter the last line prints what's the value of integers each of the friends should be assigned, and obviously they would sum up to n. Only in that way you'll be able to assign like wi integer to the ith friend, right? So let's get started. So if you think about it, if we sort all the integers that are given to us, let's say the integers are 2, 6, 8, 24, 4, something of this sorts. So these are the integers that are given to us. And now if we sort it, so we'll get 2, 4, 6, 8 and 24, right? And now let's say that there are 2 friends amongst whom these needs to be distributed. Now it doesn't take a lot of brain cells to define that the maximum numbers over here, they should at least come to a friend, right? Because what we are saying is that the happiness of a friend is the summation of the maximum and the minimum number he's having, right? So basically all the other numbers other than the maximum and the minimum integer he'll get are of no use to us, or they'll not contribute anything to the final answer. So what we can try to do is that the maximum number he's getting should be from the extreme right. If the list is sorted, only then we can get an element that is going to contribute more to our answer. So for example, over here, we'll say that, okay, 24 needs to come, or it needs to contribute to our final answer. So let's say there's a friend 1 and then there's a friend 2. Now we know that friend 1 would be having a pair of integers or a set of integers from this list, and friend 2 would also be having a set of integers from this list, and the minimum and the maximum integer in this particular list would contribute to the answer. Similarly over here, the minimum and the maximum number from this list would contribute to the answer. So we can say that, okay, let's insert 24 over here because this is the maximum number, and if it's coming in any of the list, since this is the maximum number, this is obviously going to contribute, right? So let's say 24 goes over here. Now what should I do about 8? Now if I insert 8 over here, the problem now becomes that if only 2 elements were required, then it's fine. Then 8 and 24 are both going to contribute. However, if friend 1 now takes 3 elements, so the other element would be any of these, right? In that case, 8 would neither be the maximum nor the minimum in his particular list, and thereby 8 would miss its contribution. So what we can say is, since we also want that 8 should be considered, we can put 8 into the other list. So 8 can come over here and now it would be considered. Now what? So now we can say that since 3 elements are still remaining, we'll have to define where these 3 elements go, right? So let's say that friend 1 had a capacity of 2 elements and friend 2 had a capacity of, let's say, 4 elements, right? Now we have 2 choices, that either 6 can go to the first friend and complete its list, or 6 can go to the second friend and get added over here. Now the problem being that if 6 goes to the first friend, then obviously it's going to contribute to the answer, right? But if it goes to the second friend, then it's not going to contribute to the answer, which we definitely don't want. We want the numbers that are bigger to contribute to our answer. So we'll say that 6 should go to the first friend itself so that it contributes to the answer. So the list of the first friend, it becomes 6 and 24, and the list of the second friend, that would obviously become, because 2 and 4 are now remaining, so that would become 2, 4, 8. The answer we'll obviously get is 30, plus 10, that gives us answer of 40, which would be the maximum answer. But this was a very specific case wherein we discussed only 2 friends. Now the friends could get bigger, like the number of friends could increase. Over here, the logic that essentially would pass is n log n at max, because n goes up to 2 into 10 to the power 5, and so does k. So what we can do over here is we can make a very simple observation that obviously the last elements, so friends, let's say they are k friends, right? And if we sort all the numbers or all the integers that are given to us, then in order to improve our answer, we can select the last k elements and assign all of these friends, so that at least we can assure that these key elements would contribute to our final answer, right? So these k elements are now assured to contribute. But what about the remaining ones? How would we choose the remaining ones? So even for the remaining ones, we want to select the bigger numbers first, right? So let's say a friend wants 2 integers and other friend wants 5 integers. Now if I select the first 2 integers, right, or you can say the rightmost 2 integers, that would essentially be these ones, right? Then this one would be considered. However, if I now select the first the 5 integers starting from the right, then these many integers would be considered. Let's say this many, right? And then this integer would be counted. Let me explain that better with the example. Let's say a friend wanted 3 integers and another wanted 6 integers in total. Now using this methodology, you already assigned 1 integers to both. So 1 integer got submitted to both. Now 2 integers are remaining for a friend and 5 integers are remaining for another friend. And let's say these are the 7 integers available to you, sorted in ascending order. So 1, 2, 3, 4, 5, 6 and a 7. Now you are essentially left with 2 ways. You can select these 2, right? Okay, let's try it again. You can select these 2, and then you can select these 5. So basically this would be appended to your answer, or this would be added to your answer, and this would be added to your answer, because we are gonna add the minimum element to our answer as well. So we were gonna add the maximum and the minimum element. Or in the other way around, what you can do is, so this was one way, and the other way is that these are the 7 elements you are having: 1, 2, 3, 4, 5, 6, 7. So you can say that firstly I'm gonna select 5 elements. So you're gonna select 5 elements from here, and then you're gonna select 2 elements from here. So essentially this and this would be added. Now you can just give them random numbers or increasing order: 1, 2, 3, 4, 5, 6, 7. In this case 1 and 6, that would sum up to a 7 would be your answer. In this case 1, 2, 3, 4, 5, 6, 7. 1 plus 3, that would sum up to be a 4, would be added to your answer. Obviously this case is better, right? So that's the way we are going to sort it. So what we're going to do is, we're going to say firstly let's take the k integers from the very right, and after that we are going to start utilizing the integers for the friend which has the minimum requirement of integers. I hope this makes sense and why this is working, because even the example is super clear here, that the friend which has the least requirements of integers, if it takes up the integers first starting from the very right, in that case the wastage would be less, because in this case you are only wasting these integers, right? In this case, however, you are even wasting bigger integers, that are these. Hence, since we want to even this was getting wasted, since we want to minimize our wastage, or we want to increase our answer, hence this particular strategy would work over here. Let's also look at the code. Maybe then problem would be more clear to you. So I had submitted the solution. Let's have a look at that as well. So over here what we are doing is, and one more thing is that since I wanted to explain the solution, that's the only reason I'm coding this way. Had I been doing this in a particular context, then probably I would have coded a few lesser lines of code just to improve my speed. Now what I'm doing is, I'm sorting both the values available to me, that is in V, and I'm also sorting the number of integers each friend want. Now this is absolutely fine over here, since you don't need to tell which friend is getting which integer. All you need to tell is that the total sum, right? So we don't need to maintain any adjacency list, etc. We just need to sort it. Once we are done with the sorting, I'm also declaring a vector over here called score, that would actually store the score of each of the participants or each of the friends. Then I'm traversing my array V that contains all the values or all the integers from the very right. Now if you remember, I already said that we would like to distribute 1 integer to each of the friends. that's exactly what we are going to do over here. So we are saying that the score of j, and j has initially been set to 0, in each of the iteration will increment it by 1, and this particular loop goes to j is less than m, that is, or you can say m or k as given in the problem. This is basically the number of friends he's having. So for each of the friends, I'm gonna add a particular value, and since this value would be added and this would be at the very end of the array, I'm just gonna pop it. It's just for the ease of solving this problem. You can ignore popping it and can maintain a pointer to it. But since we are already done with this biggest value, so I'm just popping it out here. I popped it out, and then I'm decrementing the number of integers he requires, because that friend got one integer, so I can subtract that. And after this loop, each of the friends would have gotten one integers, and k elements or m elements in this case would have been deducted from my entire array. After that, it's still required that the remaining elements should be distributed. So I'm going through all the friends. So I'll be going from 0 to m, that is all the friends he's having. And the special case over here would be, what if the requirement of the friend is now 0? That was essentially mean he only required one integer and he already got that integer, right? So in that case, your maximum and minimum element becomes the same, and it would have a double contribution, because let's say the only integer he requires was 5, or only integer he got was 5. In that case, the maximum is 5 and the minimum is also 5. Hence the total score or the happiness he'll be having would be 10 itself. So I'll be multiplying it by 2. If that's not the case, then I have to check how many elements more he requires. That would be stored in wj. So what I'll be doing is, in each iteration, in each of this inner iteration, I would be popping back the last element of the array, because essentially this would go into waste, right? Because let's say even if he takes up 3 elements now, then only the minimum element is gonna get calculated, or is going to contribute to our answer. So these are essentially gonna go to waste. So that's what I'm doing. I'm saying that add val is something that is the last element of this array, and let's pop it back and decrement the number of elements it requires. And once this iteration exits, at that point in time, addval would be having the last element that was popped out of the array, or this last element which this particular friend got. And because of that, we can just say that, okay, the jth friend now has gotten the value, that is addval. Fine. Once we are done with all this logic, post that, the array score, the ith element of the array score would denote the score or the happiness of the ith friend. So the problem just required us to tell the summation of the happiness. So that's what we are going to do over here. So we have a very basic function that is called accumulate in C++ STL. So we are going to say accumulate scores of all the friends. So I actually have a predefined logic for this. So all for me is basically begin and the end iterators. So I'll be saying accumulate all the elements in scores and the initial value being 0. So yeah, that's pretty much how this problem needs to be solved. And if you look at it, this is AC score, or this is AC code. Cool. With this, let's jump to the next problem. The next problem is grouping increases. So the problem states that you are given an array of size n. You will do the following processes to calculate the penalty. Split the array into two, possibly empty subsequences S and T, such that every element of A is either in S or in T. Then the second step is that for an array B of size M, we define the penalty PB as the number of indices I between I and M minus 1, such that B of I is less than B of I plus 1. The total penalty you will get is the summation of the penalties of both the subsequences, that is PS and PT. Yeah, that's pretty much what's given in the problem. And for example, they have given an example over here. So you have an array 3, 1, 4, 1, 5. And let's say you distribute now this into two arrays or two subsequences. So you pick a 3, then you pick a 4, and then you pick a 1, and then you pick a 5. So that becomes one subsequence. The remaining element is now 1 that comes into the other subsequence. Or you could have picked up 3, 4, and 5 as one subsequence, and the remaining 1 and 1 would have been the other. Also, the subsequences can be empty over here. But our entire goal is so as to minimize the overall penalty that we are going to get. And this problem was actually given by Dhruvil, who's himself an international master. And even he got a bit confused in this problem whether DP would be applicable or if greedy would work over here. So that's the beauty of greedy problems, I'll say. that no matter how much you practice, at some point in time you might still get confused, and they're always fun to solve. So with that, let's get started. So let's firstly try to simplify the problem. The problem basically states that a penalty is essentially when b of I is less than b of I plus 1, right? And since you are building a subsequences, so let's say this is the subsequence A or S and this is the subsequence T, right? And now you're gonna add elements to it. Now you can add an element to S or to T. Now all the elements, there could be n number of elements here and there could be n number of elements here as well, or m number of elements. But all these elements don't actually matter because your penalty would only be applicable. Now when you will be adding element, the penalty that may get applied would only be dependent on the last element itself, right? On the last element only it's going to define, and the penalty would arise obviously if your s of I, let's say the new element being added is s, if your s of I is less than x, then there would be a penalty, and let's say this is t of I, that is the last element, or if your t of I is less than x, then there would be a penalty. So essentially all the elements that have already been added actually don't even matter. So with that knowledge, can we simplify this problem down? So there can essentially be three cases. Now let's say, like obviously we know that there's an element Si and there's a Ti. Now let's say one is greater than the other. That's always going to be the case. Yes, they can be equal. So let's say they can be less than equal to one another. And if the opposite happens, we'll just rename the variables, right? So we can say without loss of generality that Si is less than equal to Ti. Now what are the three cases that can happen? So three cases could be that your Ti could be less than S of I, right? It could be less than equal to T of I, or your S of I could be less. Okay, so over here it's X. Yeah, so your X could be less than S of I, could be less than equal to T of I. Your second case could be that S of I is less than X of I is less than equal to T of I, right? And the third could be that X of I is greater than both. So S of I is less than equal to T of I is greater than X of I. You can include or exclude the equal to sign, that they would change the meaning by a bit, but your coding would actually handle that. Cool. So these are the three cases that we are able to come up with. Now what would happen in these particular cases? Let's try to understand it. If this is the case being handled, so let's say if it's the first case, basically your X is less than both, right? Now no matter where you add it, there would be no penalties. Now whether you should add it to S of I or to T of I, or whether you should add it to your array X, array S, or to array T. Now let's say what happens in both the cases. Now let's say you replace S of I by X. In that case, obviously your answer is gonna get reduced, but it would be reduced by a smaller margin. Let's say your X was 2, that was less than maybe like S was 6 and T was 10. Now over here, once you replace, so this is your S of I, this is T of I. Now we are saying that in case you replace S of I with X, then essentially this would become 2 and this would still be 10, right? What's the other case? You can also replace T of I with X. If you do that, then S of I won't change. So this would remain 6, but this would now become 2. Now, not really hard to say that which one is a better quantity. By better, I mean that which one has a higher value. But wait, why are we even going for higher values? Because if you remember that then a penalty would arise whenever the next element is actually greater, right? So if we want to avoid it, we obviously want that the current element we are having, the current element that we already have in the array, or the last element we already have in the array, should be as great as possible. Because if it's greater, then the chances of this particular situation arising would be minimized, right? So with that particular knowledge, obviously this seems to be better because 2 and 10 is definitely better than 6 and 2. Because over here you are just having two elements, that is 2 and 6 if we sort it, and over here you are having two elements, that is 2 and 10. So yeah, this one is better. So we can say if this case is arising, like if the first case is arising, then we'll replace S of I with X, right? Now what if the second case is arising? If the second case arises, in that case, if you replace S of I with X of I, you'll have to incur a penalty, right? Which is again something you don't want. So if that's happening, then let it be T of I. So we'll replace T of I with X. That's also easy. Now what about the third case? In third case, no matter what you do, you'll have to incur a penalty because both your S of I and T of I are smaller than X. So penalty is bound to happen, but what would you do in that case? Like, how would you even manage that? So what we can say is similar to this. Now let's say your S of I is still 6, your T of I is maybe like 10, but your X is maybe like 12. So if you replace S of I with X, then you get a 12 and T of I would still remain the same. However, if you replace T of I with X, then you get a 12 over here, but this would remain a 6. Now which one is greater? Obviously this one is greater. And since this is better, then again we replace S of I with T of I. So over here also we'll replace S of I with X itself. In these three cases, in the very first case, we were replacing the smaller element because the smaller element in these two was S of I. So we were replacing S of I or the smaller element with X. In the second case, we were replacing the bigger element with X, right? And in the third case also, now we are again replacing the smaller element with X. Now this is all we need to do, but this is very easy code. I can show you another way to code it up. Anyway, that's also easy and it's derived from the same, but just another way of coding it up. And probably if I would have seen this problem in contest itself, I would have coded something simple, similar. I'm saying that initially, no matter in which particular subsequence you add your variable to or you add your integer to, it won't incur any penalty, right? So I'm just gonna add it to X, and X and Y over here are the last most element of the two subsequences, and Y over here is 0. Now 0 is essentially a dummy value, which would obviously work in this case. The simple reason being that over here the values actually start from 1. Now since like 0 is not included in that range, hence 0 would serve as a dummy value for me. Now I'll start traversing across the range. Now I'll say that if the current element is V of I over here, if that is smaller than or equal to X of X, smaller than or equal to X, then it can be added over here. But let's just check, would it be better to add it to the other array? So we'll say that two cases could be here. The first could be if the second array is itself empty. If the second array is empty, then why do we want to disturb it, right? Let it be empty for the while, and we'll start utilizing it when we are absolutely required to do so. So let it be empty. Or then there could be a case that the element is greater than this, or you can say this is essentially the smaller element. X is essentially the smaller element, and as we discussed that in the case 1 and 1/3, if the element was being added to the one which was smaller, right? If this is the case, or the other case could be that the value of y is actually less than v of I, because if your value of y is less than v of I, or the value of y is smaller than whatever value you are currently having, this will actually cause a penalty, right? Even that is something we don't want. If these conditions satisfy, if this condition along with any of these conditions satisfy, then we want to add the value v of I to the current subsequence. We'll do that. Else if we have reached this, then either this didn't satisfy or one of these didn't, right? So let's see which didn't. So we'll say that if your y is 0, that basically means your second subsequence is empty because y is like 0 is the dummy value over here. If that's the case, or y is greater than or equal to vi, basically the lastmost value in the second subsequence is greater than or equal to v of I. This would obviously not incur any penalty. So we can say that, okay, assign it. However, if these two cases don't apply, that obviously means that the last value in both the subsequences is smaller than the current element. Now, if we come over here, that is the else statement. That basically means unconditionally the result would be incremented because both the values or both the elements at the end of both the subsequences are actually smaller than the current element. So yeah, result would be incremented. But what's this particular case? Let's have a look. And this becomes, this one. Like even S of I and T of I are is smaller than X of I. And over here, when we were discussing it, if you remember, we discussed that if you're gonna change our answer, it would only make sense to change it with the one that is having the smaller value, right? So that's exactly what we are doing over here. So if y is smaller than x, in that case replace y, else replace x, and obviously unconditionally increment the result, and at then just print the result. I hope this problem is clear. If you want, you can do it this way, or you can just do it a more generic way, that is this way. But I sometimes feel that I was able to come up with this particular solution because I tried solving it on a pen and paper. This kind of a solution is probably the first hint I'll actually get in a in a contest itself, and most likely I would have gone with it. And that's the only reason I even showed you this problem is this solution. Cool. With that, let's move to the very last problem. That is from Leetcode, and this is from one of the contests which I actually missed. So the problem states that you are given a zero indexed stringed array words having a length n and containing zero indexed strings. You are allowed to perform the following operations any number of times, including 0. Choose integers I, j, x, and y, such that obviously they are in the limits. So basically, I and j should be the indices of the words that you are choosing, and x and y need to be the indices in those individual words, right? So basically, you can swap words ix or the xth character of the ith word with the yth character of the jth word. And what we need to do is we need to return an integer denoting the maximum number of palindrome words that can be obtained after performing some operations. And obviously the number of operations are arbitrary. And then they have explicitly mentioned over here that the I and j may be equal during an operation. So what we can say over here is, since the number of operations are arbitrary, so we can essentially permute all the characters in whatever ways we want. So let's say we had a b a, we had a b b c, we have a c d b, anything of any sorts, or let's say even smaller characters, we can have a e over here and then ac. So yes, this is already a palindrome, and then we can say that okay, we can take this a up over here, we can replace this with c. So this would become a, then aa, then cba. But if you note, then what's happening, since we are able to make all the permutations, we can simply say that firstly we can have a frequency map. So we can have a frequency map of all the characters, and over here only the lengths would matter, because you are not able to change the length of a particular word, right? So all you need to know is that e is of one length. So your one of the word would be of length 1, then maybe one of the word would be of length 2, then maybe like 1, 2 and 3. Three of the words would be of length 3. This is the kind of information you need to know, right? So basically how many words of how many length you are having. Using that particular information, we can then come up with the number of palindromes or the maximum number of palindromes we'll be able to make. For example, if I say that there's a word of length 7, right? Now what you can say is that in order to make it a palindrome, we need the first like the middle element. Obviously that could be anything. However, the last element should be equal to this. The first and the last element should be similar. The second and the first element should be similar, right? So we can basically construct this entire word. And in order to construct this entire word, we already would have built this particular frequency map that we can utilize. So we'll be essentially putting the elements over here. Not even putting, we can just say that we know that we have a, let's say 6 number of times, and we have b like 3 number of times, so on and so forth, right? So we'll say that okay, the first and the last element need to be same. So any character that is having more than 2 frequencies can actually fit over here. So I'll ask a, how many frequency do you have? It will say 6. And now what I can say is 6 divided by 2 is 3. So essentially I can fill the first 3 and the last 3 elements by a's. So I'll do that and I'll subtract 6 from a. Then similarly I can come to another character, so on and so forth. But the edge case now over here would be, there's an element that is at the very middle, right? Since this element is at the middle, hence it would only require one occurrence, and any element over here would suffice. So for this, it would be best if I already have a character that is appearing odd number of times. Now let's say there was a particular character, let's say G, and G was appearing 5 times. Now since 5 is odd, hence even if and over here, if you remember when I was putting elements, so I was saying that okay, 3 would come over here, 3 would go over that. So basically multiples of 2, right? So even if I use G for that particular logic, that half of the G's would come at the beginning, half of the G's would come at the end, still it would be left with one element, right? So it would be beneficial for me to consume elements like G or any element that is coming odd number of times at the very middle, right? That's one thing. And the other being that it's always easier for you to construct an element of, let's say, length 3, or to construct a word of length 3 than to construct a word of, let's say, length 7, because this only requires choosing 3 characters or having 3 characters in total, which can construct a palindromic word. However, this would require 7 characters in total that can construct a palindromic word. Obviously, this is easier. What we can do is, using this information, we can say that we are going to sort the entire words, or we are going to sort all the words based on the length, because you don't even need the words actually. You only need the length of those words. So you can say you are going to sort all the words based on the length, and then you can traverse across this array of words, and then you can say I'm going to only pick up the length, and then you are going to try to build a word of that particular length using the frequency map already generated. I know, sounds a bit hard if you have just started programming, but this is not that hard of a problem. And I'll just show you the code. The code also isn't in C++ because logic is language agnostic. So I'll try to explain you the Python code I had written for this. So basically what I'm doing over here is, firstly I'm saying that D is a default dict. You can understand it as basically another map of character int. So basically this would contain my character and their frequencies. Then I'm going through all the words, and then for each of the characters in that particular word, I'm increasing the overall frequency by 1. I hope that particular thing makes sense. Then I'm sorting it, and the key over here is the length. So basically the final formed array or the words would now be sorted based on their length. After that, I'm going into the words, and then this is the way of traversing a dictionary. So this is the character and this is the occurrences it has. Now I'm saying that if this occurrence is odd and also the length of the character is odd, if both of these things are happening, that basically means the current character is occurring odd number of times and this word is of odd length, or it would have an element at the very middle. In that case, I can utilize this particular element. Okay, I just moved to the wrong place. Yeah. So I'll just utilize this particular element. In order to utilize it, I'll have to decrement its frequency, and I have to decrement, since I've utilized one element, I'll decrement the length by 1 as well. That's fine. But now in case the number of occurrences of this character K is more than 1 and the length is also more than 1, in that case, I can utilize some number of characters to form the remaining parts of this word. And what are the some number of characters? So basically I want to pick up as many number of characters as I want, but obviously they need to be minimum. So let's say you have having 20 occurrences of the character, but you only require 5 or you only require 6, then you can't use 20. On the other hand, you might be requiring 20, but you only have like 10 occurrences, still you can't use 20. So I have to take minimum of both. And over here, I'm dividing by 2 and multiplying by 2. The only reason is that your L can be odd, right? So in order to make it even, one of the ways is that you divide it by 2, take a int. So let's say if your L was 7, 7 divided by 2 is 3.5. I'm taking an int. So 3.5 would become a 3, and then multiply by 2 will get a 6. Similarly over here, I'm dividing by 2, taking an int, and then multiplying by 2, taking the minimum of both of them. And then whatever the minimum value is, I'm subtracting that from the length as well as from the dictionary. So now the number of occurrences would now get decreased by rem. Once I'm done with this entire iteration, I'm still checking if L is less than 2. That basically means L can be 0. That is, we are able to form the entire word, or L can have a value 1. That still means that the middle element is still remaining. But why are we doing this? Because in the above scenario, we only checked that if you're having a character that already has a odd occurrence or odd number of occurrence, then we can utilize this. What if you were not able to find any such characters? In that case, you'll have to use another character that might not be having a odd occurrence itself. So if that's the case, then you'll say that go through all the characters or all the frequencies, and as soon as you find a character which is having some frequency, which is having some occurrences, utilize that. So you'll decrease its occurrences, you'll decrease the value of L by 1, and you'll quit this particular loop. Now you'll still check if your L is having a mod 2, or you can say basically if your L is not equal to 0. If your L is still not equal to 0, that means you are not able to form this particular word. And since we have already sorted the words by their frequencies. So if you're not able to form this, you'll not be able to form the next one also, because that's gonna be bigger than this. So if that's happens, we directly break it. So we break this entire loop. If that does not happen, in that case we increment our result by 1. And yeah, let's run this. I hope I didn't change something. And yeah, let's submit this. Cool. Yeah, that was the logic for this problem, and this was a medium problem. I hope guys you were able to understand all the problems that were discussed in this video. Furthermore, I'll be providing you with a lot many problems in the description section of this video. I hope you guys solve them, and if you face any doubts, you can always and always come to my Discord server, and that place is pretty active, so you'll be able to get all the help you need. Cool guys, thanks a lot for sticking till the end. Bye bye.